Okay, so in this short video I'm going to build up the context which we're going to use to explore the different types of breakpoints in MPLAB. I'm going to use MPLAB code configurator to quickly build up something which we can use. I'm going to use a UART with a Printf, set up a pin as an output connected to the LED, and then also increment a counter which I'm going to add to the Printf, and this should give us the context we need to do pretty much everything and use all the different types of breakpoints available. Okay, so we're going to plug in the kit. Kit window comes up. We can see that we also get a notification output window. I'm going to put this on my clipboard, start a new project, standalone project, paste in part number, select the serial number of the kit, XE8 compiler, and call this breakpoints of the part I have. So, project opens. I don't have any files except a make file in the project, but that's fine. I'm going to be able to use MCC. To quickly add the files that I need. So I wanted a UART, just clicking here, add UART. Now what I'm going to do is enable transmit, 9.6 is good, redirect standard IO to UART so I can use Printf. So from the kit window we have a direct link to the schematics, and here you can see an overview of the major features on the board. First of all, you can see the programming interface for program and debug in the IDE. You can see a mass storage device for drag and drop programming with a hex, and if I just look at how the kit has come up, for me it's on drive F. There's a UART CDC on RB4 and RB6, and a debug GPIO on RA2, and you can see that's the LED. So if we look down into the schematic to see the LED, you can see RA2. We'd have to set that low in order to turn the LED on, and here again we can see the UART CDC on RB4 and RB6. So going back to the pin manager, TX, RB4, and RX is RB6, and then the LED is on RA2. GPIO as an output. Okay, now in the pin module, I'm going to name this pin LED, and I can start low, which means that the LED should turn on as I finish the initialization function from MCC. Okay, let's generate code. Complete. Now we have a main. I'm not going to use any interrupts, so I can remove these functions. I'm going to use Printf. Hello World, and just to make sure that this is the init function, new line return. Now I'm going to set up uint8, type count, set that equal to 0. So this is I'm going to use in my while loop to add a second printf, and if control space is not giving me any results, I could go to code assistance and repass the project. You can see it fixes a lot of these things here. So now for control space it picks up that option. Okay, so now I'm going to use star unsigned int /new/return and space count plus plus. Okay, I name my pin LED, so if I go LED, I can see that there's a number of functions created for me. So LED toggle, holding control down and just viewing what's in this project, define LED toggle. So it's a macro, so I still need to add a parentheses after the function. And now I need a delay function, so I can toggle at a reasonable rate. Where will I find that? I'll come down to the Piler help, and it's a PIC MCU, so I'll look in the C users guide there. Delay, how do I implement a delay? And I can see that there's a delay milliseconds. Okay, so now what we're going to do is set a breakpoint at the first line of main. We're going to open IO view to check what happens. Specifically, we're going to look at port A. Now we're going to start a debug session. Expected, we break at the first line of main, and as we step over, we can see that we clear the bit to turn the LED on, and we can now run and look at the MPLAB data visualizer. So if we connect based on COM4, which is where our Curiosity Nano is, and connect COM4 and data, and then choose to plot data on the terminal, we can see our application running as expected. We can also choose to have data on this axis here. Obviously that doesn't mean anything. And then just resetting and running again. You can see we have our Hello World in it. Okay.